Hey everyone, this week we started looking at GPIO 0. So GPIO 0 is a module for basically connecting the outside world to our Raspberry Pi. So we use it by using these pins along here. These are the GPIO pins. GPIO is general purpose input output. So each pin can be configured as either an input or an output. So for today, or for this week's session, we're going to need basically the following: Raspberry Pi, a breadboard. Okay, so breadboard is just a very easy way of connecting up components quickly for like prototyping or testing, or just like for what we're doing here, just showing off a concept. So you've got these two lines down either side. So basically each of these lines are all connected to each other. So if I plug something into the first one here, say, and this one is in particular for the ground, and then I'll have a ground all the way down along. So any one of these I'll plug into will give me a ground. Likewise with the positive, so you can plug your 5 volt power or your 3.3 volt power into any of these lines, and they will also they will power up. They'll give you 3.3 volts or 5 volts all the way down along. Okay, so then these along here all the way down across the board, so there's 1, 2, 3, 4, 5. So these 5 are connected to each other. So as you can see, I'm turning the right way around, make it a little bit easier. So I don't know if you can see the numbers. A little bit hard at the camera. So they're numbered 1 to 30 down along. Okay, so if you plug something into anything along the, say this will be 18 along here, you plug anything into that line. So I'll give you a little quick demonstration. So this is my resistor. That's plugged into a hole just there, and then I can plug my LED in. So now my resistor and my LED are connected. Okay, so as well as our breadboard, we'll need our LED. So an LED is it's a light emitting diode. So there's no real need to worry about what exactly a light emitting diode is today. The only thing we need really is just to know how to connect it. So if you can see here, I've got a little drawing. So on the move that a little bit out of our way. On our LED, I think the handiest way on this is the short leg is minus or ground. Short leg goes to ground, and also, I don't know if you can see it again. So apologies for the poor quality of the video. Also, there's a flat side on the LED. You'll see it better when you get your hands on an LED, anyways. And like as well, if you happen to cut the legs the same length, you'll know that the flat side is also goes to ground. Okay, so current will only flow across the LED from well, actual so it'll only flow in the one direction. Okay, get rid of that out of our way. So we've also got 2 buttons. So a button, they're basically just push buttons. So when you push them, they're activated. When you release them, they're not activated anymore. Okay, so current flows when the button is pushed, and it doesn't when they're not. Just another interesting thing to note about these particular buttons: they're connected across the way. So if the power comes in here, it flows to this way. So when you connect them, power will come in and come back out here this way. Okay. If you're connecting them across the way, you need to be more careful because, like I said, they work on the opposite, sort of opposite leg to opposite leg. Okay. And finally, our resistor. We're not going to talk too much about what a resistor is either. I know Dave is going to do a little bit on the theory behind electronics, and hopefully we'll have some notes or some video or something from that to share with you later. Just for now, the resistors here, mainly I think to protect the Raspberry Pi, but also to protect the LED. Just if we get too much current going into the LED, you can burn it out. And likewise, if you draw too much current from the Raspberry Pi, you can also damage it. Okay, so I suppose just connect it up. So I'd always recommend that when you're connecting your Raspberry Pi, to make sure that it's powered off. Okay, so power off my Raspberry Pi. Okay, so I'm going to connect it to our Raspberry Pi with our touch screen here. Move it over a little bit so we can. Ah, yeah. Okay. So I have a circuit. The sheet will be up on the in the Dropbox folder, and I'll probably you'll be able to download it from there. Okay. So let's see, where's our sheet? Okay. So let's hide our camera for a second. We'll have a proper look at the circuit. Okay, so we've got our two buttons wired up to Gpio pins. So the Gpio pin numbering, you've got pin numbers and then you've got GPIO numbers. So the conventional pin numbers are like 1, 2, 3, 4. So you go 1 to 40 all the way down along. GPIO then are kind of scattered all over the place. So so we've got these purple ones here are GPIO 2 and GPIO 3. On our circuit as well, we've got another one connected up here to, what is it, pin 1, 3, 5, 7, 9, 11, 13. Yeah, so that's connected to pin 13 or GPIO pin 27. Okay. What else? There isn't a whole lot. Just the on the pins. These two reddish color ones are pink on my thing here, but they're 5 volt. Over here, the orange ones, and down here again we've got 3.3 volts. So as I was saying earlier on, you know, you can connect your 3.3 or your 5 volts to these two rails here. Okay. I'm just after spotting it there now, something interesting. I just flick back on my camera for a second. So push this over. Alright, now. If you notice on my breadboard, the ground rails are on. So this one is on the outside, and the 5 volt or 3.3 volt positive rail is on the inside, and on our circuit it's the opposite way around. So just to be aware of that as well. Okay. So let's push our camera over a little bit so we have a little bit more room to play with. We can look at our circuit and our drawing of our circuit and look at our actual okay, so there we are basically. So one component, or not so much even a component, is something that we're going to use today, is our our jumper leads. So our jumper leads are very handy for, let's get rid of some of this out of the way. So jumper leads are very handy for connecting things together as well, besides just trying to use bits of cable or whatever. So we've got these ones, particular ones are female to male, so we've got a female end and a male end. So the female end goes onto our Raspberry Pi and the male end goes onto our breadboard. We've also got male to male, which we use for connecting various things together on the breadboard. So you'll see those in a second. And what else have we got? Oh yeah, that's all we need for today, but there is also a version that is female to female. So if maybe you want to plug your Gpio pin straight into a component, so say something like our ultrasonic distance sensor, you plug it in like this and you just plug it into your Raspberry Pi as well. Okay, so let's get back to where we were and wire up our circuit. Get this in a way we can see it. Again, a lot of glare off the our Pi Touch case. Okay, so our circuit has two blue jumper leads going from pin 2, our Gpio 2 and Gpio 3 to the two buttons on our breadboard. So like I said, Gpio 2 and 3 are say pin 3 and 5 on our thing. So handy way if you're counting out pins is all odd numbers on the side nearest to the rest of the Raspberry Pi and all even numbers on the outside. So again, we go 1, 3, and then we can connect that to our top line here. So now on this, our jumper cable is connected straight to our button. I don't know, you can't really see that well there, but I'll hopefully get a better view of it in a second. Okay, our second jumper lead goes to the other button. So this is from pin 5, our Gpio 3. When we look at our code later on, you'll see Gpio 3. So now I've shared, or I will share this circuit on the Dropbox, but it's also available from or that's where I took it from basically, is the Gpio 0 documentation, which is excellent. So I've downloaded a copy of it onto the Raspberry Pi so I can look at it anytime I need it. I'd also recommend that you download that or that you open that up anytime you go doing anything with GPIO, because it's really useful. Okay, so getting on with our wiring. So I'm just going to spin this around because that's the way they have it here, just to avoid confusion. Okay, so our LED is wired up to pin, I'll just count it out here again, 1, 3, 5, 7, 9, 11. No, that's wrong. 1, 3, 5, 7, 9, 11. Okay, Gpio 17. So 1, 3, 5, 9, 11. Connect that to our LED. So we just have 2 more jump relays to connect. Oh no, sorry, 3 more jump relays to connect. We also need to connect our ground. So do that now. And ground, again, if we look at our, I'll just hide my cam for a sec. We've got a ground down here we're going to use, okay? You can see here they've also used the same one. Okay. So that's it. So I'm going to set this up, get my Raspberry Pi started up, and we'll start looking at some code. Okay, so I've got my Raspberry Pi powered up and we're ready to go. Now I forgot to connect up the ground to our button, so I've already connected one up here and I just connect the second one up now. So again, from the second side of the button to the ground rail. Okay, just push that out of our way because we'll be pushing those buttons. Right, okay, so let's have a look at some code. So I've got a folder here on the Raspberry Pi where I've saved the code. Now this code is, again, it's downloaded directly from the documentation for Gpio 0. So again, if you need it yourself, just go there and you'll get it. Okay. So we're going to start off with just the LED. This will run in Python, no problem. Okay, so quick look at the code. So from Gpio 0 import LED, so we're just importing the LED function from, or the LED functions, I suppose to be more correct, from Gpio 0, the Gpio 0 module. And also there we've got from time import sleep. So that's just to give us a little pause. So the sleep function, I'm sure as you remember, is just a little delay. Okay, so here's our first setting up our LED. So red, our LED is a red LED. So we'll call it red. We could call it anything we like, but we'll call this one red anyways. If you wanted to do with traffic lights or something, you'd have red orange or red amber, whichever you wanted, and green. And so to set it up, we just give it the pin number. So LED 17 is LED, and it's connected to Gpio 17, which is pin number 11 on our Gpio out. So remember the pins here on the Raspberry Pi. Okay, so let's run, and hopefully we'll be able to see our LED on the camera. Yes. Okay, so there you go. You can see it's not terribly bright. I have a lot of light on this, trying to get a middling picture from my webcam. So it's not very bright to begin with, but with all the light running it out, it's very hard to see. But you can just see it flashing on and off there. Okay, so moving on. We'll have a look at our code for the button. I said we'd have a look at the code, but we're going straight into the program. Okay, so it just keeps printing out button is released. All we have to do is press the button, and suddenly its button is pressed. Okay, so we'll have a look at the code that makes that happen. Okay, so from Gpio 0 import button. Again, we're just importing the button functions from the Gpio 0 module. Button equals button 2, connected to pin 2 again, or to Gpio 2, which is pin 3, which is not a bit confusing. And then Gpio 3 is not connected to pin 3, it's connected to pin 5, which makes it even more confusing. But anyways, so we've got a while loop, and inside the while loop we have an if else statement. So if button is pressed, it'll print button is pressed, else it'll print button is released. Okay, so that's fairly straightforward, I think. Yeah, I don't have anything else to say about that anyways. I suppose if you have any questions, I'm going to put this on YouTube and link it to, or embedded in my notes on the Core Dojo website. So if you have any question, you could always just pop a comment onto either YouTube or the Core Dojo Athenry website. I can't promise that I'll be that quick to reply, but or I won't see it, but if I do, I'll reply to it as soon as I can. Okay, so we've got a button controlled LED as well. So let's have a look at that. So again, we're importing this time the LED and the button, and we're also importing a pause function, which is just basically all it does is it waits for a signal. So I don't want to go to make it too more complicated than it needs to be. So we're just going to again, LED is connected to 17, button is connected to Gpio 2. When button is pressed, LED on. When button is released, LED off. So these are just LED on and LED off functions that are called by when button is pressed. Okay, so again we'll run that. So this is just to show you some of the different ways as well that, you know, we have two ways there of capturing a button press. You have either when it is pressed, so you can use the dot is pressed function, or that one which was a second, I'll get back here. When pressed and is pressed. So when is basically it just doesn't do anything. It'll cycle through, whereas the other one will actually output if it is pressed. Okay, and there's several more as well, and if you look at the documentation you'll see all those as well. Okay, so run, and you can see there, just press the button, the LED comes on. Again, sorry about the, it's not going to damage anybody's eyesight, that LED anyways. Okay, and so finally for tonight is the reaction game. So we've got our code for a reaction game here. So again, we're importing our button and LED, we're importing our sleep function again, and this time we're importing random. So random is just generates a random number. I've just noticed they've used random.uniform. Normally we'd use randint, but again we'll look at the random documentation and see what is uniform and what's the difference. I have a feeling it's to prevent the same number from cropping up a few times in a row, but I'm not sure. Okay, so again we've assigned our values to our buttons on our LED. So time is basically whatever our random function here says, so it's between 5 and 10. Okay, and then it'll delay for that amount of time, it'll turn on the LED, and then whichever player presses their button first, it will print that player wins. Okay, so if player 1 presses it first, it'll print out on the screen player 1 wins, or if player 2 presses their button first, it'll print player 2 wins, and then at the end of it it'll turn off the LED. So we could stick that in a while loop and we'd have a continuous game, but for now it's fine the way it is. Okay, so we're going to run that. There we go. So we have to watch for the button to come on, and there we go, player 1, yay, I win. So I'm going to run it one more time, and we'll test if the other button is working, because we haven't actually used the other button yet. So there we go, wait for our light to come on. And there we go, player 2 wins. So I've won 2 in a row. Excellent. Okay, so I think that's it for now. I suppose next week, so far the plan is to have a look at our which is a very handy little sensor. It's the ultrasonic distance sensor. So that's it there. So it basically you've got basically a speaker and a microphone, to put it very simply, and we'll send a signal, or we'll send a sound, high-pitched, high-frequency sound out of the speaker, and we'll use the microphone to see how long it takes to travel, and we'll use that time to calculate the distance. So it's basically echolocation, I suppose, for want of a better phrase. Sonar, anything like that. So they're really cool, and there's loads of little things you can do with them. People have made like little measuring devices, or even if you have a robot or something, you can use it as well for sort of to figure out where the robot is, and you know, if it's going to bump into something or whatever. Okay, so hopefully I'll put up another video about that next week. This one is longer than I'd thought, but not to worry. The next one will be a bit shorter, hopefully. Thanks for listening. Thanks for watching. Okay.